Hello everyone, welcome to Sweetie Speaks official YouTube channel. My name is Sweetie Pinjani. This is UVM Basic series where we are learning basic UVM concepts from scratch. Today we are going to see one very interesting as well as very important topic in UVM which is called scoreboard. A lot of people say that scoreboard is one of the most difficult components in UVM. Actually, it's not. You just need to understand how to code it and you need to understand what is the purpose of scoreboard. Once you understand this, you will know how to code it. Today, we are going to see the scoreboard component in detail. We are going to see with the help of diagrams. I am going to explain you code of scoreboard step by step. Each and every line I am going to explain you. Please go through this lecture in detail. Don't skip any topic so that you understand scoreboard properly. Now let's get started. First, we will understand what is scoreboard. Scoreboard is a verification component, which means it's only used in verification. You will not find scoreboard in the design. It's a verification component. And main thing that scoreboard contains is it contains certain checkers which will verify the DUT functionality. What scoreboard will do? It will receive the transactions or sequence items from your DUT via analysis ports. And if you want to know what kind of checks the scoreboard does, it's very simple. I am going to take the example of register. What operations are possible in register? You will write and you will read. What is the main thing that you have to check in this? Whatever data you are writing should be read. That is the main thing in the register. So when you are performing right, the scoreboard will receive the right packet and that right packet will form the expected value. Whatever you are writing to the register, when you are reading that particular value only you will expect. That's why this will be the expected value. And when you are performing read, this read data is sent to the scoreboard. The read is performed from DUT. What is connected to DUT to read the output? The monitor component. This monitor component will be connected to your scoreboard. It will provide the output data of the DUT to your scoreboard, and this output data will form the actual value. You have expected value, you have actual value. Now you need to compare these two values. It can match. If it is matching, it means design is functioning as expected. If it is not matching, then you need to debug the failures. There are two possibilities. There is a test bench issue. If there is a test bench issue, you need to fix the test bench. It can be anything. Maybe the connection is missing, the sequence is not traveling properly, anything. You can debug and you will know that it's a test bench issue, so fix your test bench. However, if it's a design bug, you need to report it to the designer. Always remember, this is one of the mistake which a lot of new engineers do. Whenever your test is failing, it is not necessary that it's a design bug only. There is always a possibility that your test bench is not proper. Maybe the design changed and you did not update the test bench properly, or there is something missing or wrong in the test bench. So always consider this also. You can't just blame that there is a bug in the design. That's not how it works. You need to debug it properly. Now I told you the scoreboard component can have checkers. It can also have a reference module. Now say there is a very complicated functionality. So I will create a reference model. What this reference model will do? It will mimic your design functionality. You can also call it as a predictor. So whatever is your design functionality, we will try to mimic it in the reference model. And again, it is a verification component and it contains checkers to verify your DUT functionality. Then Diagrammatic representation is always good to remember. So scoreboard also we are going to see diagrammatically. I am going to explain you the entire test bench very much in detail, like you are going to see the picture now, and I will explain you how each and every component is connected. Now see, you have DUT, which is design under test. This is connected to your interface. Inside your test bench, you will have a virtual interface which will be connected to your actual physical interface. Then you have a driver. Driver is connected to your virtual interface. This driver is going to have a sequence item port which will be connected to sequence item export of your sequencer. We had seen this in driver sequencer connection, that we will connect the sequence item port of the driver to sequence item export of the sequencer in the connect phase. And this sequencer contains the sequences. Sequence items travel between sequencer and driver. Then this virtual interface is also connected to your monitor. All these things, your sequencer, driver and monitor together form agent, and this is an active agent because it contains driver. This agent is driving your design under test, that's why it's an active agent. We had discussed about active and passive agent in detail. There is a lecture on agent. In case you have not gone through, go through. There we had discussed in detail about this. Next, your monitor will have an analysis port, and then this is connected to the analysis export of your scoreboard. Scoreboard will have the analysis export. And as I said, scoreboard can have a reference model which will have some checkers. This reference model will mimic your design. And you can have a compare logic also. Compare logic you need because you need to compare the expected output with the actual output. That will decide whether your test is passing or failing. And then you can have a passive agent also. Passive agent means it will not have driver, it will only have monitor. And again, this monitor is going to have analysis port which is going to connect to the analysis export of your scoreboard. And then all these things together, your agent, your scoreboard, even your passive agent, come together in the environment. And then you have a test. All these things together will come inside your test, including the environment. And then you have the test bench top, which encapsulates all of them, including test, environment, your agent, components inside your agent, your scoreboard, your passive agent. Everything will come inside your top. This is a very detailed view of the UVM test bench. If you understand this diagram in detail, what each and every symbol means, how each and every connection is made, what is there in each and every component, you have understood UVM test bench. This diagram covers so much. Now let's move on. What is the purpose of scoreboard? I will simplify it a lot. First, it has to receive. What it will receive? It will receive the actual design output from the scoreboard, which will come from the monitor. Because monitor collects your design output. Then it will calculate. What it will calculate? The expected result. It has the actual result and it has to calculate the expected result. And for calculating this expected result, your scoreboard can have a reference model. What is this reference model? It will mimic your design and it can generate the expected result. Then your scoreboard has received the actual output, it has calculated the expected output. Now it needs to compare the actual and expected output. And finally, it will give the status depending on comparison, whether the comparison is pass or fail. If the comparison is pass, then design functions as it was expected. If it is fail, then you need to debug. Again, there are two possibilities. It can be problem with your test bench or it can be a design bug. Never conclude that it is a design bug directly. without debugging. You need to debug thoroughly. How do you how do you No, like in UVM, again, UVM scoreboard is an inbuilt component in UVM. From what it is derived? Let's understand the UVM scoreboard class hierarchy now. Whatever is your user defined scoreboard, that will extend from UVM scoreboard, which will extend from UVM component, which will extend from UVM report object, which will extend from UVM object, and that extends from UVM void. This is the UVM scoreboard class hierarchy. Do you create a UVM scoreboard? First step is you need to create a user defined scoreboard class which will extend from UVM scoreboard. Then inside that you will declare the analysis export, because you need to connect this analysis export to analysis port of your monitor to receive the sequence items from scoreboard. Whatever the design output comes, that is collected by monitor, and from monitor you need to receive it inside the scoreboard. For that you will need analysis export. Then you will register your scoreboard with the factory and call the constructor new. Then you will implement the build phase. The third step is to implement write method, and the fourth step is to implement the run phase. Now let's see step by step. I'll explain you each and every line of the code as I told. Let's see the first step. The first step was to create a user defined scoreboard class. If you can see, Sweetie Scoreboard is going to be a user defined class and it will be derived from UVM scoreboard since it's a scoreboard class. This is the code. Class Sweetie Scoreboard extends UVM scoreboard. Inside this, you are going to have analysis export because you want to receive the items. The output of the DUT comes to the monitor. From that, we want to receive the output. The monitor has analysis port and that has to be connected to analysis export of your scoreboard. This is the code to define the analysis export inside your scoreboard. Here if you see UVM analysis IMP, and then it is parameterized with your item, your sequence item, and your scoreboard name. And the name which I am giving is Sweetie item collected export. Then you are creating a queue of sequence item because you are going to get a lot of sequence items. It's not just one input which we give to the DUT. We give a sequence of inputs. We give a lot of sequence items and we are going to receive a lot of sequence items. I don't know how many. That's why I'm creating a queue, because queue is dynamic. It's not fixed that I will get only 5 items or 6. I don't know the size. That's why it's a queue. Then you need to register your scoreboard with the factory. UVM component utils Sweetie scoreboard. This is the syntax. Then you have function new. Since scoreboard is a component, new function is going to take two arguments. One is name and other is parent. Name is Sweetie scoreboard and then you have parent. Then you are calling super.new and you are again giving name and parent, and that's the end of the new function. Then whatever is rest of your scoreboard code, it can come here and then end the class Sweetie scoreboard. Second is you need to implement the build phase. If you see, this is the build phase. It is calling super.build phase. And here you have Sweetie item collected export. And then you are creating new. Sweetie item collected export equal to new. Sweetie item collected export this. And then end function build phase. Then you have write function. Here you can see this is the write function void write, and this function is having an argument which is of the type sequence item packet. Here you can display that your packet is received and Then what you will do, whatever packet you have, you will push it back in the queue. We had seen queues in detail in system verilog, so you can go there and understand what is this pushback method. It will push your request at the end of the queue. Okay, then that is the end of your write function. Move on to the fourth phase, which is the fourth step, which is to implement the run phase. You have a task run phase, which again inside this you have UVM phase, that's the syntax. Here you are creating an instance of your sequence item. The name of my sequence item is sweetie sequence item, and I am creating an instance sweetie sequence item instance. Now I have a lot of sequence items. What I will do, I will wait until there is a valid sequence item. How do I know that there is a valid sequence item? There will be a valid sequence item when your queue size is greater than 0. Your queue size is greater than 0, it means it got some sequence item. So this is your queue, sweetie sequence item queue. Dot size, if it is greater than 0, you are waiting until then, and when it becomes greater than 0, you are going to pop the item. Pop means you are going to get it from the queue. Whatever item came first, that you will get. Pop front means it is popping from the front. So whatever item was put in the queue first, that you will get. And you will keep on doing that till you get all the items. That's what you can do, because it's a forever loop. So until and unless your queue size is greater than 0, it will keep on running. So until you got all the items, it will keep on running. And that's the end of your run phase. Now I'll explain you entire code once again. The full code we had seen step by step. The first step was you need to create a user defined class that extends UVM scoreboard. My class name is sweetie scoreboard, which extends from UVM scoreboard. Then I need to receive the items, sequence items from the monitor, because monitor is connected to your DUT, and monitor is the component which gets the output from your DUT. I want that output inside my scoreboard because that is going to be the actual result. That's why I need an analysis export, because this analysis export needs to be connected to analysis port of your monitor. This is the syntax UVM analysis IMP, and it is parameterized by your sequence item, and it contains the scoreboard. The name is sweetie item collected export. Then you are creating a queue of sequence items. Because I don't know how many items are there, that's why queue is apt, because queue is dynamic. The size can be adjusted. The queue type is sweetie sequence item, and you can see sweetie sequence item queue. Next, you are going to register your scoreboard with the factory. And then you have the function new. Since scoreboard is a component, your new function takes two arguments. One is name. Your name is sweetie scoreboard, and second is parent. And you have super.new name parent, and then you have end function new. Then you have build phase, and you have super.build phase, and you have sweetie item collected export, which has sweetie, again sweetie item collected export. This is the syntax, equal to new sweetie item collected export, and this is the name, and this is the parent. And then that is the end of the build phase. Then you will have write is a function which contains sweetie sequence item packet. This is the packet, and then it will display the packet as received, and whatever sequence item you have, you can push it back of the queue. Whatever queue you have, you will keep on pushing your sequence item request, and then you will end your function right. Then you have task run phase. Inside that, you will create the instance of your sequence item, and then you have the forever loop. Because I don't know how many Sequence items are there, that's why I'm keeping a forever loop. And what condition this forever loop should have? Until your queue size becomes 0, because once your queue size becomes 0, it means you have no more sequence items. Until you have sequence items, you need to perform the operation. That's why inside the forever loop, if you see, I am waiting until my sequence item queue size is greater than 0. Why? Because my size is greater than 0, it means I have some valid sequence item inside my queue. And when this sequence item queue size is greater than 0, I am going to pop the sequence item from the queue. Pop front is a method in queue. You can go through the lecture on queue. It is uploaded in System Verilog tutorial series where we have discussed all these functions in the queue in detail. Pop front is one of the functions which will extract your sequence item from the front of the queue. And that's end of this if, and the end of the forever, and end of your run phase, and finally end of your scoreboard class. I hope you understood each and every line of the code, because I explained it properly, meaning of each and every word and each and every line of the code I have explained. Now let's summarize what we learned. We learned that scoreboard is a component which is used to test your design functionality. How? It has a reference model with checker. Reference model will mimic your design, and checker will check whether your actual output is equal to your expected output, and then you can know whether the design is functioning properly or not. Purpose of scoreboard, in very easy language I have tried to explain. First, it will receive the sequence item from the monitor, then it will calculate the expected result, compare the received item from the monitor, which will be the actual output received from DUT, and the expected output which you calculated, and then it will give the status depending on the comparison, which can be pass or fail. If it is pass, it means the design is functioning properly. If it is fail, it means that either there is a test bench issue or design issue. Then steps to create UVM scoreboard. You will create a user defined scoreboard class. You will create the build phase. You will implement the write method, and you will implement the run phase. This is all we learned in scoreboard. Now you can go through this lecture again, try to code whatever code I have shown by yourself and understand each and every line. Go through this lecture until you understand everything. And I will come up with more such tutorials on UVM in the upcoming sessions. If you want to stay tuned, please subscribe to switispeaks official YouTube channel. I will see you in the upcoming tutorials. Thank you.